So this unit, we are going to be looking at linear equations. We're going to be doing a lot of different stuff with them. So writing linear equations, heavy focus on word problems and real life situations. We're going to look at how to solve linear equations. We're going to look at systems of linear equations. We're going to look at some of the more major applications using like cost and revenue and break-even points and things like that. So for today, this should feel like review, okay? So these should be problems that you're like, oh yeah, like I know how to do this. We did this in Algebra 1, all right? So we're gonna go through this and hopefully it won't be anything too big of a deal. So first off, just a review of how to find the equation for a line given 2 points, right? You of course remember that your points are x and y coordinates. So the first thing that you need to do is find your slope. So to find slope, which we use m for, you use y2 minus y1 over x2 minus x1. Okay, and all the ones and twos are is they're just telling you which point you're talking about. This is the first one, so we call this x1 and y1. This is the second point, so we call it x2 and y2. Okay, so that's all I'm pulling from here. It doesn't matter which one you call x1 and which one you call y1. It doesn't matter which one is x1 and which one's x2. We could have made this x1 and x2 and that y1 and wow, no, okay, let me try that again. We could have made this point x1 and y1 and made this one x2 and y2. It wouldn't make a difference. Okay, so basically you're just subtracting the y coordinates on the top. So I'm going to do 3 minus 5, subtracting the x coordinates on the bottom. So -2 minus -1. Right? That simplifies to -2 over -1, so that's 2. So my slope is 2. All right, and don't forget that another name for slope is rate of change. That's going to be kind of an important piece as we go through here. So slope is also called rate of change. So kind of make a mental note on that. All right, step 2 is we need to find the y-intercept for our line. Okay, so the first thing that you always want to check for is check and see if you have it. Okay, so the first thing you want to do is check to see if you have it. Okay, so check to see if you already know it. Okay, and the key for that is going to be when you have a point that is 0 and then whatever the other number is, that would be your y-intercept b. Okay, so b is y-intercept. All right, so if you have a point where the 0 is the first coordinate, then whatever the second coordinate is b, that's what a y-intercept is. Okay, so in this particular instance, I don't know that. If I did, we could just grab that number and we'd be all set. Since I don't, option 2 is we are going to plug m and one of the 2 points, doesn't matter which one, into y equals mx plus b and solve for b. Okay, so I'm taking y equals mx plus b. All right, and I'm going to use one of these 2 points. It doesn't matter which one. I think I'm going to go with this one because I like the numbers 2 and 3 better than I like the numbers -1 and 5. But it doesn't matter. You could use either. Y coordinate at that point is 3. We just found m, our slope is 2, times the x coordinate at that point, which is -2. And b is the thing that I'm looking for. So multiply these guys, that's -4. And solve for b. So I'm going to add 4 to both sides, and I get 7. All right, so that's step number 2. And then once you know those 2 things, the last thing that you're going to do is actually write your equation. So my equation is just going to be y equals the slope times x plus the y-intercept. And there's the equation of my line. Okay, so like I said, this should be a review. I went through it kind of fast, but you can go back and rewatch it if you need to. But this should be just kind of review stuff for you. Okay, so now let's take a look at this one where we're going to have this as an actual word problem. Okay, so in the year 2000, there were 56,000 golden retrievers in the United States. In the year 2005, that number had risen to 68,000 golden retrievers. So the first thing we're going to decide is if we're given 2 points or if we're given a point and a slope, okay? And how do you tell the difference? So remember that slope is the same thing as rate of change. So when we talk about slope, that is the same thing as a rate of change, So if there's a spot in the problem where they tell you like you're getting $20 more every week, or the temperature is going down by 5 degrees a minute, right? That would be a rate of change, and that's your slope. Okay, but in this particular problem, we don't have that. What we have is instead is two different pairs of numbers that are associated together. In the year 2000, there were 56,000, and in the year 2005, there were 68,000. Okay, so what we actually have here is we are given 2 points. Okay, so we're given 2 points, two pairs of numbers that go together. Okay, so now we're going to write our equation. Okay, so first thing that you have to do when you're writing an equation is define your variables. So the two things that we're talking about in this problem are the years and then the number of golden retrievers. Okay, so I'm going to say that X is equal to the year, and then Y is equal to the number of golden retrievers. Retrievers. There we go. All right, so my 2 points then are going to be the year 2000 and then 56,000. And my other point is going to be the year 2005 and then 68,000. All right, now for this particular problem, I'm using the numbers all out. We're going to see some problems in this unit where instead of using X to just represent the year, we might say something like X is the number of years after 2000. So we would change the numbers that we used here. Another option is that instead of just saying the number of golden retrievers, we could have said the number of golden retrievers in thousands and then just made this 56 and 68 and used it from there. It really doesn't make a huge difference, but we'll do it all different ways during the course of this unit. All right, so now I'm going to figure out my slope because I don't know what that is yet. If we already knew the slope, I wouldn't have to worry about this. So I'm subtracting my y coordinates, and then in the bottom, I'm subtracting my x coordinates. Okay, when I subtract these two, that's going to be 12,000, right, divided by 5. All right, and then just throwing that into a calculator, and it works out to 2,400. So that's my slope. Okay, so what that is telling me, this is my rate of change. So what this is telling me is that every year there are an additional 2,400 golden retrievers in the United States. Okay, so that's the interpretation of what that number means. All right, so now that we know that, now we got to figure out our y-intercept. So in this case, the y-intercept, remember, if we knew the year 0, how many golden retrievers there were, we could shortcut this. Since we don't, I'm going to have to plug into y equals mx plus b. So my y coordinate, I'm going to use that top point. 56,000 is equal to 2,400 times the x coordinate, which is 2,000 plus b. Okay, I'm going to multiply those together. So 2,400 times 2,000 is that number. 48, let's see, 1, 2, 3, 4, 5 zeros, I believe. All right, and then I'm going to subtract that from both sides. So I'm doing it kind of backwards on the calculator and just recognizing that this is going to be negative. It's a really big number. Okay, so let's stop and take a look at that and see if that makes sense. So what this is telling me is that this is an estimation for in the year 0, right? So from the year 2000 all the way back to the year 0, that they're estimating that this is how many golden retrievers there were. Okay, so 2 things to make note of here. 1, the models that we set up for different real life situations really only work for a very limited time scale. Obviously, it does not make sense to say that in the year 0, there were negative 4 million golden retrievers in the United States, right? That doesn't make any sense whatsoever, okay? So most of the time when we use these kind of models, we just use them on a smaller scale, which is why we might define our variables to be something other than just X is the generic year, okay? So even though this seems like it'd be kind of like a nonsense answer because it doesn't make sense, it works for this model. Like our actual equation of 2,400x minus this 4744 number, right? So this equation will work to give you an estimate of how many golden retrievers there were, as long as you're doing it in a fairly limited time scale, like maybe in just the early 2000s or like the very late 90s and the early 2000s or something like that. Okay. All right. So then this last question, how many golden retrievers would you expect there to be in the United States now? So what I'm going to do is I'm going to plug in X equals, and this is the year 2020, right? So I'm going to plug in 2020 for X. Now, for this particular model, this is pretty far off from the data that we have. So I'm not really expecting this to be super, super accurate. It's going to give us a good guess, but it's really kind of far out from the data that we have. And a lot of things can change between the year 2005 and the year 2020 in terms of golden retrievers. So we can use our model to make this prediction, but we don't necessarily expect it to be super, super, super accurate. Oof, something like that. All right, and then I'm just going to throw this into my calculator. So 2,400 times 2020, and then minus this 4744000. And it works out to about 104,000. Okay. And you can sort of do a check. Does that make sense? Well, we were at 68,000. We're adding 2,400 a year for 15 years. So yeah, that seems ballparky, like it would be right. Okay. So these problems should kind of make sense, and you should be able to sort of think your way through them. Okay. The big things that you should be working on this unit, this mathy part, this should all be review. You learned this in Algebra 1. Okay, the big things that I want you to be focusing on in this unit is making sense of what do these numbers actually mean. Okay, when we say that our slope is 2,400, I want you to be able to tell me that that means that every year we're adding about 2,400 golden retrievers. Okay, I want you to be able to tell me what the y-intercept is and how does that make sense in this problem, or how does it not make sense in this problem. Okay, so those are the big things that you really want to make sure that you're focusing on in this unit.